prime. That's what this is saying? Okay. This right here, anyone know what that's called? No? It's called a differential equation. It's an equation that involves a function, y, and its derivative, or within the equation. So when you take a differential equations class, you'll be given this equation, and you have to go figure out what y is. So you would start with this. You would have no other information, just that. And from that, you've got to figure out what this is, which means you've got to get to this. Okay? Differential equations. For those of you who are going to have to take engineering analysis, something like that, you'll be doing differential equations. All right. That one was a little bit fun, right? Just a little bit. All right, so let's say for now we're done with taking the derivatives of those exponential functions for now. What's next in line then? The log functions, right? The log functions. If somebody gives you a log function, what is its derivative? So if you are starting here with y equals log base a of x, so a general logarithmic function, then the derivative of this is this. 1 over x natural log a. That's it right there. That's the formula. That is in your formula sheet, right? Let me see. You have it open there. Is it 12?
Yes.
Yeah, formula 12 on reference page 5. 1 over x natural log a. So now, as an example, if y is equal to log base 3 of x, what's its derivative? 1 over x natural log 3. And remember, natural log of 3 is just a number, isn't it? Right? Okay. If y is equal to log base, no, I'm not going to put base. I'm just going to put log x. What's its derivative? Careful on this one.
X.
1 over x. Natural log what? 10. Where is the 10 coming from? It's base 10. You only know it's base 10 because they wrote log. So you have to know that. You have to know that that's the base 10 log. I'll erase this. Next example, and the important example. What's the derivative of the natural log of x? It's 1 over x, natural log of e, right? Because what's the base of the natural log function? It's e, right? Even though it's not written. So the base of that's e, so I put in the formula natural log e, but what's natural log of e? It's 1. So this is really just what? 1 over x. The derivative of the natural log of x is 1 over x. The derivative of e to the x is what? E to the x. Derivative of natural log of x is derivative of sine of x. Cosine x. Derivative of cosine of x. Negative sine. Derivative of tangent x. Secant squared x. So those, you've got those memorized. Remember the first day we learned those? You didn't quite have those memorized. You didn't feel that comfortable with them, but now you feel better. You want to get to the point now where derivative of e to the x is e to the x. We all say it at the same time. Derivative of natural log of x is 1 over x. Okay? Those are Those are the big ones for today. Derivative of e to the x and natural log. Now, let's see how we would take derivatives of things where now we have a little chain rule involved, maybe some product, some quotient rule, right? But incorporating all this. So how about this one? What if y is equal to log base 4 of x plus sine x? And I want to know the derivative. Okay, so that's log base 4, right? This is composition. You have chain rule going. The last thing happening is the log, right? So that's the first thing you differentiate. So go ahead. 1 over x plus sine x, right? Because we're saying, what's the derivative of log base 4 of my hand, right? Is 1 over my hand times natural log of 4. Not done though, right? You got to go inside, right? Derivative of what's in there, which is 1 plus cosine x. Now, a lot of times we'll take this right here and we'll just slide it up top. So we'll just make that be 1 plus cosine x over x plus sine x. Jackson, what was your question? Did you have a question? No, that 1 plus cosine x is on top. That makes sense, that one? All right. All right, next one. Now we're mixing it up. Where are those things? There they are. Daniela. I don't see Daniela. Let's see. Youssef? How's it? Is this kind of making sense? Yes. Okay. So when you look at this, what are you seeing? Are you seeing, I don't know. What are you seeing? What are you thinking? I want the derivative. Same thing, right? So just rewrite the whole thing because this is derivative of an exponential function. Okay, same thing. And then you said times what? Yes? 5. Okay, good. Everyone got that? The derivative of the of an exponential function is going to be itself, but then you have to do natural log of whatever the base is. But we're not done, right? Because now that you've taken derivative of the exponential part, Youssef, you want to keep going? We're going to multiply this chain rule now times what? 2x. Okay, now I need this in parentheses, okay, because I'm going to get two terms, right? So I need 2x and then plus, drum roll, 1 over x. That's it. That's it. That's the derivative. Yeah? I've got a fun one for you. Okay. Ronnie? Shit. Ronnie? What do you got, Ronnie? One over secant x. Everyone on board? Yes? Times finish it up with the chain rule. Right, because everyone, I should point this out. This is natural log of secant x, right? This is not natural log times. There's no multiplication here. It's composition. So Ronnie, all you're missing now is the derivative of what was inside. Secant x tangent x. So we multiply this by secant x tangent x. Which is tangent x. Tangent x. Okay, so we got to be careful here. The derivative of tangent x is secant squared x, yes? That's not what we just did. We took the derivative of something and it gave us tangent x. It's kind of weird, but that's what it is. I'm just curious. I wonder what the derivative of, I don't know, cosecant x is? Just curious. Natural log of cosecant x. So derivative of this would be 1 over cosecant x times derivative of cosecant x, which is negative cosecant x times cotangent x. And the cosecants cancel, but you'll still have a negative there, right? Right? What you get what? Negative cotangent x. So if I would have put a negative here, right? Then it would put then this would have been positive cotangent x, right? These natural logs are kind of weird. And there's just no way to get good at this. Just you got to practice. Natural log of the natural log of the natural log of x. What's its derivative? Okay, so 1 over what? What's the whole thing? Natural log of natural log. Another natural log? No, just those, right? So it's like we were doing natural log of that first, right? Derivative of natural log of that is 1 over that. Now we say times. Now we're doing this natural log of this stuff, right? So 1 over the natural log of x, right? And then now we have to take derivative of this, which is 1 over x. 1 over the natural log of x times 1 over the natural log of x times 1 over x. Ready for the next one? You're ready. You're ready. You're ready. Oops. Take the derivative. So I'll come back next week and I'll see how far you are. This looks like a mess, doesn't it? Quotient rule. Quotient rule. And then you got product rules with chain rules. This looks like a disaster, doesn't it? Doesn't this look like a disaster? What's that? There's no logs, yeah, so why am I throwing this at you all of a sudden, right? Okay, so I want you to just follow me here, all right? I'm introducing you to something new right now. Just follow me, tell me whether or not you buy into this or not, all right? What I'm going to do first is I'm going to take the natural log on both sides of the equation. We are going to get more into this next class. I just wanted to kind of introduce you to it. We'll do a more formal explanation of this next class. But we're kind of running out of time, and I thought this would be a good thing to show you. Do y'all agree I can do that? Yeah? Okay, now, next line. Okay, what did I do there? Expanded. I'm using properties of logarithms. If you have log of something over something, right? Division, you can turn it into two logs with subtraction between them. That was a property of logs that I had on the board earlier. I said natural log of a over b is equal to natural log of a minus natural log of b, or something to that effect. So if we have division, it turns into two logs. All right? Now, I'm going to keep going. Are there any questions on that? Okay, natural log of y equals. All right, we have natural log of something times something, right? I have multiplication here, which means I can split that into two logs. Natural log of 2x plus 1 to the fourth plus natural log of 3x minus 1 to the seventh. And then what about the other log here? This log. Multiplication again, right? So I can split that into two logs. Now you have to be careful here because we have a minus sign, don't we? So when this splits into two logs, the minus will go to both. So my next line is going to be minus natural log of 4x plus 1 cubed plus minus what? Minus natural log of x plus 1 to the fifth. Yeah? I'm getting there. I'm getting there. I'm almost there. Almost there. Next line, natural log y equals 4 natural log 2x plus 1 plus 7 natural log of 3x minus 1 minus 3 natural log of 4x plus 1 minus 5 natural log of x plus 1. What did I do there? Exponent rules of logs. I've done no derivatives, right? I've done no calculus at this point. Nothing. Zero calculus. It's just been using algebra to take that big ugly thing, and we're expanding it out to look like this. Y'all okay with that? Now, at this point, if I wanted to take the derivative, I could. Okay, because I started with an equation. I took natural log on both sides, right? So whatever I do to one side, I do to the other. So I'm maintaining equality. And now I've gotten into this. This actually is nice because if I were to ask you to take derivative of this, what would you do with the 4? Just bring it down, right? Because it's a constant down front. Can you take derivative natural log of that? Yeah, it's 1 over that times the derivative of that, right? And then times the 4. Can you take derivative of this? 7 comes down. It's 1 over that, right? Times the derivative of that. Minus 3. 1 over that times the derivative of that. Understand? So this is much easier to work with. No product rules, no quotient rules, nothing, right? Everything's been ripped apart, and we can do them just one by one. The question, though, is how do you handle the left side? Because you have to take derivative on both sides, right? This is no longer y. So all we're going to do is pull out the good old implicit differentiation. I know it sounds bad. It's not that bad, though, okay? I want the derivative with respect to x on both sides. So very carefully, what is the derivative of the natural log of y with respect to x? So what's the derivative of natural log of anything? 1 over it, right? 1 over, in this case, y, times chain rule, derivative of y, dy dx, right? Isn't that what we're solving for? I mean, isn't that what we're asked to find? Right there? That's what we're trying to find, right? Okay, equals 4 times, now derivative of this with respect to x. What do we say that would be? 1 over 2 plus 2x plus 1 times 2, which is the derivative of the inside. Plus 7, derivative of natural log of 3x minus 1. 1 over 3x minus 1 times 3. Minus 3 times 1 over 4x plus 1 times 4. Minus 5 times 1 over x plus 1 times 1. So I don't need it. I'm really close to being out of time. Does anyone have any questions so far? Yes? No? Okay, I can clean this up, can't I? Just a little bit. I'll do the 4 and the 2 together. That gives me 8 over 2x plus 1. No parentheses. Plus 21 over 3x minus 1. Minus 12 over 4x plus 1. Minus 5 over x plus 1. Right, that's what this side is, yes? I'm just putting numbers together here. 3 and the 4 is 12. Put them on top. Now, the left side is this, right? But I just want that, right? So I'm going to multiply both sides by what? By y, right? Multiply by y. Here it goes away. Multiply this side by y. It appears over there, yes? But what is y? The original expression. So when I say here, multiply this times y, y is really, I forgot what it was, actually. What is it? 2x plus 1 to the 8th, right? Oh, to the 4th, yeah, I need to account for the chain rule. And then 7th over 4x plus 1 to the 3rd. And then x plus 1 to the 5th. That's the original, right? That's y. And this is your derivative. That's your derivative. It ain't pretty, but we didn't have to use any quotient rule or product rule or anything like that. This method that I just did on this example is what's called logarithmic differentiation. And that's what we'll continue with next class. So what I want you to do for your homework out of this section 3.3, do not try and go past number 40. Well, hold on. No, don't do any problems from 51 on. Yeah, from 51 on, you can't, we haven't talked about, okay? All the other ones, you should at least, you know, give them a shot. Any questions?